Good morning everyone. Welcome to Tejasri Electrical Engineering YouTube channel. In this video, we have to learn online course Electrical and Electronic Measurements, Part A Electrical Measurements, Chapter 2 Basics of Instruments. Instruments. An instrument is a device in which we can determine the magnitude or value of the quantity to be measured. The measuring quantity can be voltage, current, power, and energy like this. Generally, instruments are classified into two types. They are absolute instruments, secondary instruments. Absolute instrument. An absolute instrument determines the magnitude of the quantity to be measured in terms of instrument parameters. This instrument is rarely used because each time the value of the measuring quantity varies, so we have to calculate the magnitude of the measuring quantity analytically, which is time consuming. This type of instruments are more suitable for laboratory uses. For example, tangent galvanometer, rel of current balance, and so on. Next, secondary instruments. Secondary instrument determines the value of quantity to be measured directly. Generally, these instruments are calibrated by comparing with another standard secondary instrument. For example, voltmeter, ammeter, wattmeter, like this. Practically, secondary instruments are suitable for measurements. Secondary instruments are classified into three types. They are indicating instruments, recording instruments, integrating instruments. First one, indicating instrument. This instrument uses a dial and pointer to determine the value of measuring quantity. This instrument will give instantaneous values of the quantity to be measured. For example, PMMC-MI-Dynamometer type wattmeter, frequency meter, form factor meter. Next, recording instruments. This type of instruments records the magnitude of the quantity to be measured continuously over a specified period of time. Recording voltmeter, recording wattmeter, storage oscilloscope, CRO. Next, integrating type instruments. This type of instrument gives the total amount of the quantity measured over a specified period of time. For example, energy meter, ampere hour meter. Instruments may also be classified on the basis of method used for comparing with unknown quantity with unit measurement. These are classified two types: direct measuring instruments, comparison instruments. Direct measuring instruments. In this, energy of the measured quantity convert directly into energy that activates the instrument, and the value of unknown quantity is measured or displayed or recorded directly. Comparison instruments. These instruments measure the unknown quantity by comparison with a standard one. For example, AC and DC bridges, potentiometers. These comparison type instruments used in case of high accuracy measurements are required. And instruments are classified according to the principle of operation they utilize. The effects they utilize are magnetic effect, heating effect, electrostatic effect, electromagnetic effect or induction effect, and Hall effect. First, number one, magnetic effect. Whenever a current carrying conductor placed in a magnetic field, it produces a force according to the Lorentz principle. force F equal to BIL sin theta. The direction of that force is found out by Fleming's left hand rule. According to that principle, first, number 1, the force between current carrying conductor and a permanent magnet. Here the measured current is flowing through a coil. It produces a imaginary bar magnet and it is movable coil. When a permanent magnet is placed near to this imaginary bar magnet, it produces a force of attraction or force of repulsion. According to this force, the movable coil is moved and measured current is indicated on the instrument. This effect is utilized in permanent magnet moving coil. Once again, consider the coil of figure 1. Figure 1, current carrying conductor and a permanent magnet. It produces an imaginary bar magnet and carrying current. When a permanent magnet is brought near it, there will be a force of attraction or repulsion. If the coil is mounted on a spindle between the bearings, there will be a movement of current. This movement is according to the measured current magnitude and direction. This effect is utilized in permanent magnet moving coil instruments, PMMC. According to Lorentz principle, the force between two current carrying conductors. Consider here two current carrying conductors. Current carrying conductor 1, the current is flowing through the current carrying conductor 1. It produces a imaginary bar magnet. According to the current direction, it produces north and south pole like this, and it is fixed coil. Next, current carrying conductor 2. When a current is flowing through the current carrying conductor 2, it produces a imaginary bar magnet and this coil is movable and arranged a pointer on the scale like this, and this imaginary bar magnet is placed near to the first coil. Then the force is produced between the two coils and one of them is movable. This movement is according to the force of attraction. A scale is moved according to the measured quantity. This effect is utilized in electrodynamometer type wattmeters. Once again, consider a two current carrying conductors like this. For the direction of current shown, the two current carrying conductors produce unlike force near each other and there is a force of attraction, and if one of the coil is movable and other is fixed, here current carrying conductor while one is fixed and it is movable, there will be a motion of movable coil. This effect is utilized in electrodynamometer type wattmeter. According to the Lorentz principle, force between current carrying coil and sharp iron disc. Consider a current carrying coil. When a current is flowing through the coil, it produces an imaginary bar magnet, north pole, south pole, like this, and this coil is fixed. When a sharp iron piece which is not magnetized earlier which is movable, is placed near to the end of the coil, then the force of attraction produced between them. If this moving iron piece is pivoted on a spindle between two bearings, it swings on the coil and indicated on the instrument. This effect is utilized in attraction type moving iron instruments. Once again, consider a current carrying coil in above figure. It produces an imaginary bar magnet. When a piece of soft iron disc which has not been previously magnetized is brought near the end of the coil, it will be attracted by the coil. Therefore, if we pivot the soft iron on a spindle between two bearings and a coil is mounted near it, the iron piece will swing in the coil when the latter is carrying current. This effect is utilized in the attraction type moving iron instruments. If we have two pieces of soft iron placed near the coil, two are similarly magnetized and there will be a force of repulsion between them. This type of effect is utilized in repulsion type moving iron instruments. Next, the thermal effect. The current to be measured is passed through a small element which produces the heat on it. The temperature rise is converted to an EMF by a thermocouple attached to the element. A thermocouple consists of length of two dissimilar electric conductors joined at the end to form a closed loop. If the junctions of the two dissimilar metals are maintained at different temperatures, a current flows through this closed path. This current can be measured and is indicative of the root mean square value. That means RMS value of the current flowing through this heating element. This principle is utilized in thermal effect instruments. Next, electrostatic effect. When two plates are charged, there is a force exerted between them. This force is used to move one of the plates. The instruments working on this principle is called electrostatic instruments. Usually this effect is used in voltmeters. The voltmeters which is used for measuring the high voltages. We have to discuss about the electrostatic voltmeters in later. Next, another one, induction effect. When a non-magnetic conducting pivoted disc or drum is placed in a magnetic field produced by a system of electromagnet excited by an alternating current, an EMF induced in the disc or drum. If a closed path is provided, the EMF forces a current to flow in the disc or drum. The force produced by the interaction of this induced currents and the alternating magnetic fields makes the disc move. This effect is mainly utilized in an AC energy meters. We have to discuss it in energy meters later. Next, another one, Hall effect. If a strip of conducting material carries current in the presence of a transverse magnetic field as shown in figure, this current direction magnetic flux Hall affecting material and its Hall voltage is measured between the two edges of the Hall affecting material. an EMF produced between two edges of conductor. The magnitude of the voltage depends on the current, flux density, and property of conductor called Hall effect coefficient. The EMF may be measured after amplification. Hall effect elements are extensively used in magnetic measurements. They can also be used for sensing of current. And also this effect is used in Poynting vector wattmeters, which is used for measuring of the power loss, which is used for the power loss density at the surface of the magnetic material.